So hi engineering Janta, welcome back to the episode 3 of WTF series of statistics, and this is for data science and this is for absolutely free of cost for all of you. And today we are here in the episode 3. Today we'll be learning about measure of dispersion and we'll be learning about variance. But before that, confirm if I am audible and visible to you. Just drop a yes if I am audible and visible to you, and then we'll begin. If I am audible and visible, straight away drop a yes in the chat section and then we can begin. Great, great. Thank you so much. Thanks a ton. So I am visible and audible, and henceforth, yesterday we had covered the measure of central tendency. Today we'll cover the measure of distribution, fine, or the dispersion, which we often say. Now, for central tendency, good evening Vaibhav, good evening demo channel, good evening Sumant, hi everybody, good evening yaar. So fine. Let's try and understand today. First of all, yesterday we covered a few things, mean, median, mode, and in that, if you carefully remember, you learnt that median, I'm starting again from there and then we learn the measure of dispersion. So median, this handles outliers, right? Primarily for outliers, but we also studied something called as mode, right? What does this do? Fine, we agree that a lot of elements which are occurring, or high frequency elements that are occurring, are generally given by mode, right? जिसकी frequency सबसे ज़्यादा वो mode है ना? But the frequency that is given by mode is of what use? किस काम की है? Where do we use it? Fine. So take a data. For example, I take a data of hospital, fine. You have some patients, patient ID, fine. You have their names and you have their gender. So primarily male, female, female, male, and so on, fine. Now you have this patient ID, this would be a unique number, integer type value, you will have names which are different, but this gender is a categorical data, right? It includes a category, either male or female. So this is a categorical data, right? And that is why, it being a categorical data, here mode plays a very, very crucial role. So whenever somebody asks you, where is mode useful for categorical data? Why so? Let's understand why it is useful. For example, if I want to know who is dominating in this data set, males or females, mode can simply straight away tell you that. You do not need to calculate an average of males and females. You straight away go to mode, whoever has highest frequency, it would automatically come on top. It would automatically reflect as a result in mode. Okay? Hi Vibhuti, hi, good evening. So I hope that this much is clear to you. Fine. And let's go ahead and now today, let's understand today's topic, which is nothing but measure of dispersion, right? And we will understand it in such a manner that first of all, before going to tools like we went to mean, median, mode, before that we understood what is central tendency. We understood that, right? Now we'll understand what is dispersion, fine? We'll understand what exactly this term means, and then we'll go ahead and we'll see why do we need this measure of dispersion, fine. When we were having measure of central tendency, जब हमारे पास mean, median, mode था ही, तो हमें इसकी ज़रूरत क्यों पड़ी? Fine. Why do we need this when we have central tendency? Fine. So let's understand that. Consider a data set. Consider that you're in a class. You have two sections of a class, 10th A and 10th B. Everybody has done matriculation. So I hope these are the marks of 10th A. Okay. Here I am going to write marks of 10th B. Now here I say that for 10th B, people were quite studious, so 70, and then student 2 scored 80, and then what? Then you have 90, then somebody is scoring 80 again, fine. Then what should we do? Somebody can again score somewhere around 70, fine. So what would be the final sum of all these? So 80 plus 70, 150, 150, 150, 300, 300 and 390. So basically this is 390. The sum of it, the summation of it is 390, right? And if I calculate its mean, then what would I receive? So 390 divided by 5, that is what I would get, right? So when I try calculating this 390 by 5, what would it deliver to me? So I can go ahead, 5 7s are 35 and then 5 8s are 40. So 78 comes out to be the average marks of it, fine. You now know this is the mean for it. We'll understand about dispersion. Wait for a while. So there is a doubt. Basically it will sort the data according to the frequency. Means if females are higher, then all data get sorted according to female. Yes, it can be there, but primarily mode gives you the output of the highest frequency. अभी उतना ही समझ के चलो, ठीक है? We'll go later on, we'll study it even more, fine. But अभी के लिए it is not about sorting. It is never about sorting. Mode will return the maximum occurring value. For example, you have 100 patients, out of them 60 are female, 40 are males, so it would return female as the output. Mode gives you the highest occurring frequency element, fine. The element which has highest frequency, that would be mode, as simple as that, ठीक है? अभी उतने पे रुकते हैं. Now mu is here average that I calculated for 10th B is 78, that works. Now let's go to 10th A and let's see what is happening here, fine. So there is one person who has 40 marks here, there is one person who has 50 marks here, and then there are 3 people who have 100 marks here, fine. And then again, if you see, the sum is again 390. If I try calculating the mean, it is again 390 by 5 and again 78. Strangely, both have same mean, isn't it? Same average. They both have same average. Then what is the use of this mean? Now tell me, in such case, can you measure which class is studying good? You cannot, because here there is a certain set pattern where everybody is scoring around 70, 80, 90, 70, 80, 90. So everybody is above average, can be considered above average. But here, 3 people are exceptionally intelligent. One is actually lingering somewhere around average and one is very prone to go into the below average category, 40 marks, fine. So this is also having the same mean, this is also having the same mean. How do I differentiate into these 2 data sets? How do I differentiate? Fine. And if you see here, the values that you have are very near to mean. 80 is very near to mean, isn't it? If I plot it on a graph, say like this, if I plot, fine, and here from 0 the values start and values go up to infinity, fine. And then if I say that you have 10, 20, 30, 40, 50, 60, 70, 80 and 90, and let's go ahead further, थोड़ा सा और आगे चलते हैं, fine. So it would be 100 somewhere here, and now let's plot these particular values here, fine. इन्हें plot करते हैं. So I plot the first value, this is 70, fine. Another one is 80, fine. And then you have 90, then you again have 80, so I'm making one more value here, fine. So it is superimposed only. And then you have 70, so one more value here. Now when I calculate that this is the mean for this is, which color should I choose? This should I choose. So this is somewhere here, the mean is here, right? From mean, if you carefully see, the data is near the mean only, isn't it? The distance between actual data points and the mean is not very large, right? Now let's plot for, this was for 10th B. Now let's plot the same thing for 10th A and you will find what is dispersion. Fine. Usually people don't teach dispersion in this depth because you don't sometimes feel the need of it. However, when you dive in deep into the concepts, you will feel what is dispersion. Everybody will straight away say variance and standard deviation and interquartile partition and various other things. Fine. Range, they'll introduce a lot of tools. But what exactly is this dispersion? That we are understanding right now. Fine. So 0 again, 10, 20, 30, 40, 50, 60, similar. Fine. 70, 80, 90 and 100. Fine. So these are the marks for, again, the marks distribution for 10th A. Let's plot. Fine. So for 10th A, I'll go with the red color and 40 is here, 50 is here, then few people are straight away, 3 people are on 100. So that is the distribution. Now if I calculate mean, where does the mean lie? So I would say 78 is the mean again, and this is the mean somewhere here. Now you carefully see and tell me whether this particular portion is far away or not. Fine. Here if you see at this particular place, there are a few values. I'll go here, see. There are a few values given. 40 is very far from its mean, right? 50 is also very far. Then if you check about 100, it is also lying somewhere away from the mean that you got. This is 78. Fine. This is also 78. But the difference is that here the mean is nearer to the actual values. Here it is not. So there is a significant difference in both datas, and this difference from the mean, the difference from the mean of the actual data elements is called dispersion. Fine. This distance of actual values from the mean value is called dispersion. Now you got what is dispersion? Central tendency is 78. For both it is same, but the dispersion is very, very different for both of the data. Is it clear by far? If you understood what is dispersion, just give me a yes in the chat section. Otherwise, दोबारा समझेंगे, कोई issue नहीं है. आप, if you want to ask 20 times, you ask 20 times, I'll explain this, fine. But I promise you, I am not like that teacher who will say this and not explain. You ask me 20 times, I'll explain this to you 20 times, fine. So if it is clear to you, just drop a yes in the chat section. You got what is dispersion? Then drop a yes. If you didn't get it, simply write no. Great. Thank you for typing out yes. I hope to everybody it is clear. And yes, I can read your yeses. Great, great. Good to go. So let's proceed further. Let's go further. Fine. Now you got what is dispersion. Now, if I want to differentiate between this data set, give me a minute. Yes. So now if you want to differentiate between this data set, you know that dispersion can help you out, right? Now, if you want to measure this dispersion, how do you measure it? You need some tools, right? For them, the tools are variance and standard deviation. Fine. Today, we will study variance only, and tomorrow we'll study standard deviation. Fine. So guys, I would request you keep the chat section interactive so that I can also make you understand things and I can gauge whether you're getting the things or not. Fine. So let's go and study variance. Now I hope everybody knows about sample data versus population data. For those who don't, go ahead, watch the previous episodes. Fine, that would help you out. Now, let's go to the variance. What is variance? Fine. For population data, there is a different formula. Fine. And for sample data, there is a different formula. Okay. For population data, there is different formula. For sample data, there is different. Great. So now, for population data, if I go ahead with mean, fine, you know mean was mu here, right? So when calculating variance, variance is represented by this symbol, sigma square. Fine. This is for population data. For sample data, it is represented by S square. Okay. This much is clear. Let's go ahead and let's understand this. So when let's remove this mu, I don't need it right now, and I'll write the formula for this and then I'll explain you. So what is sigma square? This is nothing but 1 upon n, fine, summation of I equal to 1 to capital N, because population data was capital N, right? Then xi minus mu whole square, fine. I'll show you what exactly and how exactly you get the standard deviation for it. So this is the variance for it. So this is the variance formula for population data, and for sample data it is 1 upon n minus 1 summation of I equal to 1 to n xi minus x bar, fine, and again square. Now this is 1 upon n minus 1 and this is n. So this is nothing but the difference between the mean and the actual value. So I told you this is dispersion, the distance between the actual value. So this is xi and this is mu. Difference between them, that is squared and divided, the summation of all divided by the total number of elements, that is for population data. For sample data, you're subtracting minus 1 from the total elements. Now why are we doing that? What is exactly that? I'll explain you. Wait karna uska. Let's stay here for a while. Fine. I'll explain you why we need this particular thing. Fine. So now let's go ahead and let's calculate for 10th A and for 10th B. Both we'll calculate. Fine, for 10th B. For both classes I'll calculate. So xi I am writing mu, and I am writing xi minus mu. Fine. Let's write the square itself. And then here also xi mu and xi minus mu का square straight away. ठीक है? So if you correctly see for 10th A, this is the data 40, 50, 100, 100, 300s, right? So I'll write 40, 50, 100. I hope it is visible. Yes, it is visible. 100 and 100. Coming to the mu portion, it is 78, 78, 78, 78, again 78. Fine. So I'll take help of my calculator. Fine. Being engineer, I'll rely on my calculator. So straight away I'll subtract it from my calculator and let's check it. So minus 38 is the result that we get here. Fine. And then what I'll do is, wait a minute, 78 minus 40. Yes. So I'll square it up. So this comes out to be 1,444. Now all of you who want to know how it came, the difference between them is 38. I squared 38. Okay, इतना ही किया मैंने. Basic maths चल रहा है. Fine. Now let's do 50 minus 78. This is 28, and 28 into 28 is 784. Fine. And then 78 minus 100 is 22, and I square it up. So 484, and this would be used thrice. Now if this is 484, fine. Now if I check their summation, now if I check their sum, what would be their sum? So 1,444 plus 484, which will be used thrice, right, and a 784. So you have 3680 here, fine. So this value is 3680. The sum that you get here is 3680. So sigma square for 10th A, fine, I am writing it here, 10th A. Variance basically for 10th A is 3680 upon 5, which is 736, right? This is the variance that you are getting it, fine. Now for 10th B, let's try calculating this. So for 10th B, it is 70, 80, 90, 80, 70. Okay, 70, 80, 90, 80, 70. If I am not wrong, this was the distribution, right? 70, 80, 90, 80, 70. Yes. And now again 78, 78, 78, 78 and 78. And this will show you the actual difference. Now this variance will show you the actual difference between both. And this is only on the population data. Right now we are not doing it on sample data, so I'll remove this sample data thing. Everything I'll remove from here. Fine. So that I can show you the difference. Let's remove it. We'll write it later on. Fine. Now see here. Here, if I try calculating this, 70 minus 78 is 8. 8, 8, 64. So basically when you subtract this, you get minus 8. When you square the minus 8, the negative gets cancelled. You get 64. When you do it here, you get 4. 90 minus 78. This is 12. 12 and 12, 144. Squaring 12 is 144. 80 minus 78 is 2. 4 and 70 minus 78 is 64. So now when I do the summation for it, so basically when I calculate sigma square for 10th B, now you will yourself see the value of variance will decrease, and henceforth you will find the variance is less, the dispersion is less. See, 64 plus 4 plus 144 plus 4 plus 64, and henceforth 280 divided by 5. So see, 280 divided by 5, which is nothing but 56. Now imagine yourself, see the difference here and see the difference here. Fine. The variance for 10th B, the variance for this class, 10th B, sigma square of 10th B came out to be 56. Sigma square of 10th A, rather I should write it on the different slide, right? Not on this, so that when I later on give you this PPT, you have a better understanding of things. Fine. So here I'll write it. So sigma square of 10th A is 736, and for 10th B, where people were scoring good throughout, right, this is 56. You can yourself see where is dispersion more, isn't it? Dispersion ज़्यादा यहाँ है, यहाँ नहीं है. As simple as that. Now this variance gives you a matrix or a number which shows you that the distance between the absolute values and the mean is quite large in 10th A, whereas in 10th B everybody are almost similar. Now if you see, this value is somewhere near central tendency, but this value is far, far away from central tendency. Fine. So that helps you measure dispersion. Is it clear by far? By far, is variance clear? Is its use clear? By far, we have just done it for population data. Is it clear to you by far? Tell me. By far, is it clear? Yes or no? अब तक मजा आ रहा है, समझ में आ रहा है? Is it clear by far? I'm waiting for your yes. You type it out and then I'll proceed. If not, I'll again explain it. अगर समझ नहीं आया दोबारा समझेंगे इसको. Go ahead. फटाफट बताओ. Is it clear to you? Okay, Ansh. Great. Thank you, Ansh. So, let's go ahead and let's move further. So, you saw how it behaves on population data. Now it's time for sample data. Fine. So, variance on sample data. Now, the reason sample data variance is often different, see what happens here. Sigma square here is 1 upon n minus 1, summation of I equals to 1 to n, again xi minus x bar, which is mean, ka square. Now, if you see in sample, here let's take the same example. In sample, I take these two, fine, these two values, 40 and 50, fine. I take these two as the sample. Now, if I take these two as the sample, what I'll get? 40 plus 50 is 90, divided by 2, this is 45. This is my x bar, isn't it? Let's do it there. So if I take 40 and 50 as my sample, because out of this whole population data, this is complete population data, I pick these two as my sample data. So I'll go further, I'll use for 10th A, I'll write sample data. This is 40 and 50 marks, Now if I try checking the mean here, what would it be? 50 plus 40, 90, 90 divided by 2, this is 45. Fine, this comes out to be as 45. Now when I try checking xi, this is 40, then it was 50, then it was 100, right? It was 100 3 times. So when I write this x bar, what does it come out? 45, 45, 45, 45, 45. Now I take the difference xi minus x bar, fine, and I square it out. So what will I get? Here I'll get 25, here I'll get 225. Why so? 40 minus 45 is 5, 5 ka square 25. 50 minus 45 is, sorry, here again it is 25, so not 225, pardon. Here again it is 25, so 50 minus 45 is 5. Fine, again 5 ka square 25. 100 minus 45, it is 55. Fine. I'll take your doubt, wait for a while, I'll take your doubt. Now because I've started this, I cannot end this, so wait for your doubt, stay till the end. Fine. 55 into 55 is 3025. Fine. And then again this is also 3025, this is also 3025. Fine. Now if I calculate the sum of it, so what will it come? 3025 into 3, and then I can have 50 added to it, because 25 plus 25 is 50, divided by 5, this comes out to be as 1825. Now if I simply divide it by 5, it would come out to be as 1825. Fine. Now what I am trying to do, now let's remove all this, and now let's understand what exactly we are trying to do with n minus 1. You saw how long it was coming out when I divided, what kind of dispersion was existing there. Fine. So the mean that we got was 45, that much you agree? Now that was very extrapolated value. So for sample data with everything, the formula also got removed. So for some sample data, sigma square is 1 upon n minus 1 sigma of xi minus x bar ka square. Now we'll understand this, why n minus 1, because with n a huge value was coming up, right? But with that huge value, the problem was this x bar, isn't it? This was coming very far from the actual mean, right? And when it is squared, the error becomes even big, right? So choosing sample is very, very important, number one. This is the first lesson you get. Fine. Second thing is, when you try and find out this particular sample and you try finding out with samples like 50 and 100, when you take these as your samples, then your mean would be significantly far from this. Fine. Your mean would be around what? 50 plus 100 is 150. If you divide 150, it would be around 75. Not so far, but still nearer to it, far. What if I do 50 plus 40? You have very far, you have 45 as your mean. So this dispersion would exist if you take bad samples, number one. Number two, the reason you need n minus 1 is, when you are finding for a sample, you saw the difference there, right? You saw the difference. Now, had I done n minus 1 in the variance, the value would not have been that extrapolated. Fine. It would have been lesser. You could reduce this distance. Why so? The distance that is being increased, when I would have done n minus 1, which is 1 out of the sample, what we can do is we can close up this distance. For mean, it would be closed. Fine. Closer value of variance means better performance. We'll come to it. We'll come to it. I'll answer this doubt, don't worry. So this way you can move somewhere near the particular portion. For example, here, in which it was a good distribution, not very diverse distribution, here also if I take this 70 and this 70 as my two samples, great to go. But if I take 90 and 80, 170 if I take, and then I divide by 2, then I would get 85 as my mean. Fine. And 85 is somewhere here. So that would be far from what actual mean is, right? So you need to understand that this particular thing that we are doing here, this n minus 1, that we are trying to do here, what happened? This particular thing that we are trying to do here is called Bessel's correction. Fine. This is called Bessel's correction. Why so? You know this mean was problematic when I showed you. This mean was problematic, and due to this a lot of problems were further occurring. Henceforth, this is basically underestimation of population. Fine, इसे underestimation of population कहते हैं. And this underestimation of population, to avoid this, we do this n-1, and this is called Bessel's correction. This is an interview question, and you can straight away learn it out if you want to. This name is Bessel's correction, but do understand what exactly it is doing. Fine. Now let's go and let's understand. So closer value of variance means better performance. Somebody has asked that if the variance is closer, the performance is better. No, it's not like that. It is just that the data is less distributed. Fine. Variance is showing you the distribution. If variance is high, then from mean, the actual elements are very far away. Whereas, if it is not so far away, if the variance is lesser, then the data and the actual mean are very near. Henceforth, my central tendency is very useful for me at that point of time. Fine. So I hope this doubt is clear. Whoever asked this, so closer value demo channel, is it clear? So closer value of variance means better performance. No, it's not like that. I'm just telling you that the diverse data or the distribution of data is quite far from everywhere. Fine. If the variance is very high, then from mean the distance is a lot, it is widely distributed. If from mean the data points are nearer, then the variance would be lower, or the variance is lower, then data points are nearer. Is it clear by far? Okay, great. So it is clear. So that's pretty much for today's class. आज की क्लास को यहीं पे विराम देते हैं. Fine. And whatever good you learnt, take it with yourself. Fine. And that is very, very essential and important that you take some good lessons with you. Fine. And I would suggest one thing: whatever good you've learnt, pass it on. Teach people. Teach it for free. Fine. So that there is an information about statistics, about AI, about ML. The reason being, we Indians missed the information revolution. We Indians missed the industrial revolution. We Indians missed the software revolution. Most welcome, most welcome. We Indians must not miss the AI revolution. Fine. So let's educate even the basic of our citizens with statistics, with AI, with ML. So this is for statistics only. You go ahead, learn this out, make notes of it. Fine. I'll share this PPT however in the community. But do one thing, make your notes well. I hope measure of dispersion and variance is clear. Tomorrow we will study standard deviation. Fine. So I'll wrap this up here. I hope everybody's doubts are clear. Fine. Also, you can get in touch with me at my Instagram handle, which is Shuklaji Speaks. You can go ahead and follow that out. And if you want to connect to me, or if you like something, you can write to us at support@prepinsta.com. So that's pretty much, I guess. And this is a community handle that I have where you can find this PPT. Go ahead, join that community if you want this PPT. Fine. Have a wonderful day ahead, guys. I'm wrapping this up. Keep doing good without